Sane person? Non-sane person.
Okay, so you say sit bad and good, right? This is the wild card. I'm going to curves on my paper.
It's not as nice as like curves.
It says P.
And that's what
A hairdresser cut off like this much hair. And after that it's like it turned like a dark color and started to curl a lot more. She was like, all that was dead hair. It was all split ends and it's horrible. So you know,
Quiet, please. So, probably Democrat given mail. So I didn't total them for you. But you do have to total them. So there's 200 there. Oops. 200 there. So 400 overall. Although you never actually really need that number. 30, 170, and 200. So probability of Democrat given mail means I'm only looking at the males. I cover up the females. How many males are there? It's 200. How many of those are Democrats? It's 80. So that is 80 out of 200. Or 0.4 if you reduce that. Female given Republican, so I'm only looking at the Republicans. There are 170 of them. 60 of them are female. And then our male Democrat independent. So that's the hardest one up here. Are A and B okay? I think this is the hardest one. So male Democrat, are they independent? So you got to test it. If the two things are independent. So there's this, I wrote it over here, but you got to show me that when I do that, when I give you the extra piece of information, the probability doesn't change. So if it's true that the probability of Democrat is equal to the probability of a Democrat given male, if that's true, what extra information did male tell us? Or what did extra information mean? Nothing. If these are true, then male doesn't mean anything. And if male doesn't mean anything and has no impact, that's what independent means. So I need to find both of these and see if it's true. Well, I already found this in part A. Isn't that 80 over 200? So that's Democrat given that I know they're male. What's the probability of Democrat just in general? Like flat out, all Democrats, all people. 200 out of 400. So, probability of being a Democrat in general is 0.5. If I tell you, so this isn't really equal, it's like a question. If I tell you that it's a male, now I say, what's the probability of Democrat? It's 0.4. So did the fact that male was included change the answer? Yeah, so the independent or dependent? Dependent. But you gotta prove it. You can't just say no because and then make something up. There's gotta be like a mathematical proof. So you have to work this out. You're kind of going, okay, are they equal? And then, so no, they're not equal. So, dependent. Questions on that part? Yeah.
You have to do that, or could I go like so if I eliminated the 80 males, it would no longer be 200, it just be.
Say that again.
It's like out of the 200 Democrats, if I eliminated 80 males,
What does that do for us?
if there's changes, males, like you had 0 males, you can't have 200
she changes 400 all the days.
Well, but then like any number would change all the time if you got rid of. You know what I mean?
Yeah.
Okay.
Could you test it
So yeah, I was gonna bring that up. And I just chose dem. Like here, I got a choice. I can do male given dem or dem given male. I chose dem given male just because I already had done it in part A. I didn't feel like doing it again. But you can choose either way, and they'll both come out the same. They're either independent or you're not. It doesn't matter which way you present it. Yeah.
Like the way that I kind of did is male and dem. I compared the probability of dem given male versus male given dem. I recognize how it's wrong, but like how, like, with the, I don't know what I'm. I'm sorry. Like how do you?
I didn't know if that was like a realization or if you were like,
Like I'm trying to figure. I'm not sure. I know what I want to ask, but I'm not sure how to ask it. Like how do you break that?
That puts me in sort of a tough
I know.
spot.
Sorry.
Can we talk about it like individually later?
Okay, sure.
Maybe you can rephrase. Maybe we can talk together and see what your question is.
Sorry, Steven.
So, all right, part B or number 2, I guess. I asked this the opposite of what you're used to. So you gotta kind of. Did everybody do it? Use the Venn diagram to find this? Did it work? You know what the answer is? It would be point 8. Yeah. You got point 8. Okay. So what I'm thinking is the formula, but if you guys want to do the Venn diagram, we can talk through it. I just would never think about it that way. So your formula for OR, oops, that's in. Your formula for OR is add up the first one and the second one and then subtract what? Subtract the overlap, right? So the part in the middle, if you look at the Venn diagram. Usually I give you these 3 things and ask you to find this one. But here I gave you these 3 things and ask you to find that one. It's just algebra, I'll just change the variables I give you. So A or B is 0.2. Probability of A is 0.7. Probability of B is 0.3, and then it's minus the probability of A and B. And this is what we're looking for. So, you know, this is 1. So what would I have to subtract from 1 to get me to 0.2? Would be 0.8, right? So the answer is 0.8. I've never really tried to do this with a Venn diagram. So the probability of one or the other find out on the next one, I guess. Question on what I did though to get 0.8? You're just using the formula. This bottom one, so probability of A given B. What's the formula for that? What goes on top? Probability of both. What goes on the bottom? Probability of the one that was given to you, which is, in this case, B. So A given B is probability of both, which I told you was 0.3, divided by the probability of the one that was given, so 0.5. And if I reduce those, I get 0.6. Well, what was the probability of A in general? 0.6. Then the probability of A, if I know B is true, is still 0.6. So, does B matter? Probability of A is 0.6. If I know B is true, the probability of A is still 0.6. So, do we care about it? So, are they independent or dependent? They'd be independent because I got the same answer to both of those. That's what independent means. And then B given A, I can work the same way, so B given A, again, it's the probability of both divided by the probability of what's given to you. That would be 0.3 divided by 0.6, which is 0.5. Well, what was the probability of B in general? It was 0.5. So did A have any impact? Not, so are they independent or dependent? you guys have no clue what's going on, or if you're like bored because I'm talking about it. It's good?
Yeah.
Okay, well, no one's answering me, so I'm not sure what. Alright. You don't know what I usually say everyone, and it means like you. Yeah. This guy?
Yeah, so like feel like 0.7 plus 0.3 minus 0.2, or is that just a question?
No, that's what you do.
Okay.
But that's what the formula tells you to do. You just
Okay.
you do the diagram.
That diagram, I set it up wrong because I put 0.2 in the middle and then 0.5 on the left, 0.1 on the right. But when you add all those up, and you get 0.8. Is that a coincidence? Or
Yes.
that's
Yeah.
Those are the numbers that I use.
Because you're using the or in place of the and, so they're not always going to be the same. Yeah, that's not going to work every time. Let's look at your homework.
Also,
Yeah.
I did finish it,
Okay.
so that you're not mad at me.
It's okay.
Sorry.
It's okay. You get A's, so that's what I'm gonna say. Alright, I lost the one I did, but I mean I can do it again quickly. Let's go check it. So probability of yes given female. There are 50 females, 8 of them said yes. So 8 out of 50, which would be 0.16. Male given no, there are 60 no's. 18 of those were male, so if we divide that, that's 0.3. Yeah. Alright. Number 2 is tougher. So I gotta find out if they're independent. So to see if they're independent, it's those two formulas and I want to see if they're equal, right? So I want to know, does the probability of A equal the probability of A given B? Well, A is the probability of getting heads on the first toss. So what's the probability of getting heads on the first toss? 0.5. So then the question is, does that equal 0.5 or not? If it does equal 0.5, are they independent? Yes. If it doesn't, they're not. So the probability of A given B is the probability of A and B. It's the probability of both divided by the probability of what's given. But those are tough in this situation. So if I flip 2 coins, what are the possible outcomes? Heads, heads. Oh, why am I doing that? Heads, heads. Heads, tails. Tails, tails. Tails, heads. Okay. So A and B means 2 things. You got head on the first toss, and both tosses have the same outcome. How many of these have heads on the first toss, and both tosses are the same? One of them. That's that one, right? So what's the probability of that one happening? 0.25. Event B is both tosses have the same outcome. What's the probability that both tosses will have the same outcome? 2 out of 4, so 0.5, right? Well, what's 0.25 divided by 0.5? How many times? That's a half, right? So they are equal, so are they independent? Yes. And that's your work. Like it says, explain your reasoning. You proved it. Your math is your reasoning. Question out? That's a tougher one, I think. 3. So there's a crap load of words. I went to the end and I was just like, so he arrived late, had to park in a no parking zone. What's the probability he'll get a ticket? So the probability of ticket given that he parked in the no parking zone. Because you don't get a ticket every time you park there, right? Just kind of look at the draw. So the formula says that's the probability of both divided by the probability of the given. The given is getting parked in the zone. So what's the probability of both? Bless you. That's not the right answer. 0.07. And that's just right here. The probability that it does both, it tells you it's 0.07. And when the probability has to park in the zone, I'll tell you that too. 0.25. If you divide those, you get 0.28. How many had that one? Questions on it? Like, does it make sense now that I went through it? Because they're not responding to it. I can't tell if they understand this. Alright. Number 4. So, cards questions screw some people up. We got 52 cards. 26 of them are red. That's just like how a deck of cards works. So we're playing a card game. I got 52 cards. I shuffle them up. I randomly deal you one. What's the chances it's red? 26 out of 52, which is half. So half the cards in the deck. Alright, now you're going to give me the card back. I'm going to reshuffle again. Give you the one on top after I shuffle. What's the card? What's the chances that's red? Still 0.5, right? So there's still 26 red cards and there's still 2 red cards. But that's not what this example did. This example said I deal them one after the other. So I shuffle them all up. I got 52 cards. I deal you a card. What's probably that card is red? 1/2. But now I deal you another. Like, I'm not taking that card back. You're holding on to it. So now how many red cards are... And we want them both to be red. So we kind of got to assume that first card is red that I gave you. So now how many red cards are there? 25. And how many cards are there? 51. So it wouldn't be 1/2 times a half. It would be 1/2 times 21 over 51. So 25 over 102, I guess. So if they replaced it, they're independent. Like one deal has nothing to do with the next deal. But if I don't replace it, you see how the probability changed? That's dependent. I have less cards now. It's a different game now. So the probability changes. Question on that one?
So it's like, when is it dependent, independent again?
This is dependent because like this would be independent if the probability is the same every time it's independent. So if I give you the card, take it back, and now we're starting the same game over, that's independent. But if I deal one and you keep it, now that's changing the odds. And when we change the odds, that's dependent. Alright. This one seemed to confuse people, but it's not. I don't know, it wasn't designed to. I think you guys just overthought it almost. So, probability of a home buyer selecting 2 card garage is 0.7. 1 card is 0.2. When I say or, you add up the 2 possibilities and you subtract what? The overlap. But is there any overlap here? So I just gotta add the 2 possibilities, that's just 0.9. I can't buy a house with a 1 car garage and 2 cars. Well, I guess I could. I don't know why that never happened. Find the probability let's select no garage. Well, 0.9 chance they'll choose 1 or 2, and I guess there's no 3 car or more, so what's left over is just 0.1. And the probability they will not want a 2 car garage, that's like the probability of 2 complement, basically. So what's the probability of a 2 car garage? 0.7, so what's the probability you don't get a 2 car garage? 0.3. Is that right? Alright, this one down here. So, they say this here, but that was really unnecessary. Suppose the probability of a randomly selected person as a smoker is 0.25. Well, we knew that, because what do those 2 add up to? 0.25. This is 0.75. Now, you can do this with the formula, or you can do it just kind of thinking through like a Venn diagram type scenario. Let me do the formula first, then I'll show you how that fits. So this is the probability that I get cancer given that I'm a smoker. So I have probability I get cancer, and then I know that I'm a smoker. So that's the probability of both and smoker. No.
Gets cancer. 0.08.
0.08, right? Smokes and gets cancer. Divided by the probability of smoker. What's the probability of smoker? 0.25. So what they're saying is don't look at the people that don't smoke. What's the total percentage there? 0.25. Out of that, how many people smoke? 0.08. There's your fraction. 0.08 on 0.25. Just like the Venn diagram. So then if I divide that out, it's 0.32. How many had that right? 0.32 then. Oh, nice. That's more than I thought. Alright, good. No, I didn't mean that mean way, but like walking around the ones I looked at, had it wrong, so I must have just looked at the bad ones. Alright, probability does not get cancer. Probability of no cancer given that they are smokers. So it's probability of both. Divided by the probability of smoker. What's the probability I don't get cancer if I'm a smoker? 0.17. Probability of smoker is still 0.25. This is 0.68. That makes total sense because what should these two add up to? Should add up to 1. Because if you smoke, you're either going to get cancer or you're not. Those are the only two outcomes there. And then for the bottom two, they just tell you to look at the non-smokers instead of the smokers, but it's like the same type of idea. So I'll talk through these like the other way. Given that they're a non-smoker, so I'm just going to kill these. These don't even matter anymore. What's the probability of cancer? Well, what's the probability of non-smokers in general? How many non-smokers? 0.75. Out of those who gets cancer? 0.04. Whatever that, I don't even care what it equals. This would be 0.75 on the bottom, and now I want them to not get cancer. So now what's the probability? Now what goes there? 0.71. I mean, you can leave it like that as far as I'm concerned. But I'm scared that you know where I'm getting the numbers from. Do you know where I'm getting the numbers from? Okay. Question. Alright. Is that what you want me to do? Yeah. I was just debating like what to do next. So set notation. It's really easy. You guys just think it's hard because you haven't learned it. Which makes sense. It's like embarrassing how much in high school I would just sit there before and just try to draw those things. This is what they ask you, right? They'll give you that. They'll say like, what's A and B? Yeah. A or B? Okay. And then there's like a slash one they use, right? It's like A slash B. No, it's like a diagonal though, right? I don't even know what the diagonal is. Does it go top left to bottom right? Top right to bottom left. So like this? I mean, you can figure it out either way. Alright. So A, this means what? And or? It means and. Because it looks like an A. That's how I remember. So A and B. So that means they've got to be in both. So what numbers are in both of those lists? No. It's got to be in list A and in list B.
4 and 6.
So that's just 4 and 6. That's why we're doing. Everyone. So this is A or B. This means it just has to be an either. So mislead. Which numbers?
I did this last night though. I got this. Yeah, I got it.
It really helped you. I can see. What numbers are in either list? All of them, right? basically you're just listing every number. And then this last one means A, but not B. So I want every number that's in A, but is not also in B. So 3, 5, and 7. Does that make sense? That's all it is. Like, that's the whole thing, right?
I'm so bad.
Even use how to use a hint or person anything.
I know, but I didn't want to. I didn't want to set myself up to fail because then I just got to do all of it.
Wait,
Wait, you didn't even look at the hints?
No.
Why?
Because
That's what you do. Fail immediately, get the hints, and then you.
Yeah. You know how to do it, fail, read it, learn how to do it, and then get it right the next time.
multiple choice. It's like at the
Alright, I think you're really missing the point of the Khan Academy here. It's to learn for your test.
It's okay.
Right, that's fine, but like don't just click through nonsense.
Or
And
point at
that's,
me.
because you just said I click through nonsense.
Oh my god.
Does that help? Okay. I want you to do this, 6.3c. And I'm also going to back up the due date on time. We're not through all the stuff yet. I thought we would be a little faster. Really expect the value is the only thing I have to get to. Yeah, it's going to be Sunday. For all of them. So we'll do, there's only one topic we haven't covered yet. I'll get to that tomorrow. Yeah. Yeah.
So if you switch, there was like A/B in the bottom right.
Yeah.
That like switches in any way because there's like a meaning for like B but not A.
Yeah. So then that would be everything that's in B, but not in A. So 2, 4 is an A, so that's no good. 6 is an A, so that's no good. So that'd be 2, 8, and 10.
Okay.
Yeah, I could ask that both ways. Alright?
Yeah, I just know if it's like something from the lines. The line stays the same.
You would just flip flop the letters.
Okay.
How far back do you go?
I wrote it on the freaking board. And said the date. Like, where do you go? Taylor, are you doing quiz 6.3c?
Yeah.
Okay.
Wait, what quiz?
Yeah, so that's he's on that too. So I'll do multiplication rule. We'll do that next 2 days.
Sometimes, yes. It's on.
Oh. Yeah, don't worry about 6 and 7 on this sheet. But multiplication rule is on your con too, I think, isn't it? Isn't multiplication rule on your con also? Do you have your assignments pulled up in front of you? Is multiplication rule one of the assignments?
It's not on this.
It's not. Okay.
I'm at my dash to work.
Okay.
Okay, so
We already answered the question.
what am I looking for?
Nothing.
Multiplication. Goodness gracious. No, I had to.
What is the line?
X, but not Y. You just did. How do I speak?
No, I know.
just gave you. No, that's not homework. That's we should be checking that soon. But so yeah, I'll go through. What'd you get?
I don't know. I don't know. I'll keep it aside.
What?
I said I don't know. Like, what's A and what's A? B.
Well, you can choose whatever you want. So it's woman and professional degree. So you can make A woman and B professional degree, or the other way around. You do either. 5 is the one I'm really worried about. That's the one I keep like asking you questions and nobody answers. And I'm like, do you get it or do you not understand? You say you get it. I'm not convinced. It's fine if you don't. I'm just not convinced. Do I have to go? Okay, so for me to change the actual date on con, I have to click on all 15 of those assignments and change the date. Should I do that, or can we just say it's due Sunday? I should do that. You want me to do that?
I'll finish it before Friday, so I don't have to look at it and say,
I'll
just leave it.
Yeah, it does. If you see over here,
It's just
Yeah,
gonna
like if you can see the date, it's just kind of, yeah, just leave it out. If you can't, it just says late after a certain time. You might want to change it.
Yeah, I'll change it. Plus, Caleb's gonna forget what day it's due anyway.
Yeah. What day was the deal?
so I had to work on Sunday, so I couldn't turn it.
Right. I've had this assignment for 2 weeks, but I had to work last night.
5-hour shift.
5 hours.
Right.
That sounds like
A
fun.
5-hour shift.
I wish I worked 5 hour shifts.
Me too. My shift's there. 7 hours.
You work a lot too.
Are we good on this? Or are we still working on 5? Are you done? Sid, are you done?
I am done, sir.
You got number 5?
Stumped at this point.
I forgot the formula.
It's on the freaking board!
I don't know how to get to A. I got it already. I know we went over it, but I don't know.
You don't know how to do one part?
We'll get to the last. I know the first part. That's PA. But then on a solve to the PA, line B. Whatever you call that.
What did you call A? Let's check the top 4 first. Are the top 4 okay?
Yes.
Yes.
You did decimals? So 0.526, 0.474, 0.405. Does that matter? Do you agree with the numbers? Alright. So you gotta help me figure out what the hard part is for number 5. So I want to know, are choose a woman and professional degree, are they independent? So, like, are we stuck right there? I don't know where to start. So the first thing I would do is call them A and B. It doesn't matter which one you call which. So I'm just going to call woman A and professional B. Doesn't make a difference. You can do it either way. It could work the other way too. I'm going to write down the freaking formula, as I call it.
I know what it is.
Okay, what is it? Don't look at your paper.
Well, that's how I was gonna
Well, so you don't know it. You just know how to read. It's a different thing. What's the probability of what goes on top? Probability of both. Divided by the probability of the one that's given, right? So what's the probability of both? What's the probability of woman and professional? Okay, so look at the chart. How many professional women are there? 30. Out of how many people? 4. Did you say 4?
No, I think 74.
74's not even right. It is under like.
74 is at least on the chart.
Yes.
4 is okay, so 30 out of 1626. On the bottom is the probability of B, which is professional. So what's the probability someone's a professional? How many professionals are there? 74 out of. So in reality, those 1626s are going to cancel. And we don't really need them. I'm just like putting them there to show you where it came from. But this is going to be 30 over 74. So that's the probability of woman given professional degree is 30 out of 74. Does that part make sense? Are you with me?
Yeah.
It doesn't tell me if it's independent or not. What do I still have to check to see?
The probability of one of those, like in general.
No, not one of them, a specific one.
Okay.
I have to check woman because that's what I did on the left-hand side over here. So what's the probability of woman in general? How many women are in that table? 856 out of how many people on the table? 1626. Agree? With me? If those two come out the same when I do the decimal division, like when I divide them, are they independent? Yes. If they don't come out the same, are they independent? No. And I can just look at them. Like, this is less than half, right? This half of 74 would be 37. And this is more than half. Because half is 1600 to 800, and we're above that. So the decimals do not come out to be the same. So no, since the probability of woman given professional is not equal to the probability of woman. So when I gave you this extra information, it changed the probability. I didn't tell you, I'm wearing yellow socks. What's the probability someone got a professional degree? Those are quite related. These are related because the probabilities change. So it seemed like there was a lot of confusion on that one. Does that help? Not really.
You still remember how to get the A-Y?
Whatever. The given thing. Like the formula, or just deciding which is A and which is B? So the one that is on the freaking board?
No, like
That one? So no, I'm trying to understand where it's from. That's the hard part?
It's like reading that one question like 50 billion words and you're just like, where the heck do I start? That's how I feel.
But this question isn't that 50 billion words.
Yeah, it's just, I think it just sets a new concept.
Okay. Alright. No homework. We'll practice more tomorrow.
That's a crap.
Can you tell me where to look?
I am dying.
So, if I said to you, what's the probability of someone is a woman and a professional? You have to go, okay, there's 30 of them. But there's 16 days. All the people in the world are about dirt.
Okay, here's the thing. I'll give this back to you.
A woman. I'm sorry, what's my favorite?
No, he can throw them out.
They're all about dirt.
I'm reading more inside out. He's scared, so he's find a way instead of he's all.
So it's always like what you want over everything. That's what I said.
She said she's because this is between my dad and I. I mean, I think
How she got it? That
she's really not gonna graduate now, even though I'm pretty sure.
Sydney doesn't have a
Sydney
science
doesn't
credit.
have a science
She
credit.
hasn't got it picked it up. She has three science credits.
She has to have a graduation.
I don't like my dad said this is your gift, you know, like
I'm done thinking out loud, Miss Davis. I just try to say what I believe.
You said like such
like
random
that.
things.
You're still
Oh, good call. Steven likes to get the full class.